Good evening, all of you. Welcome you guys. Welcome you all. Here, first of all, you all of you do comment. Am I audible? Is the audio video is clear or not? Of you, and please do comment. Is the audio video is clear to all of you? Audio video is clear. Everybody, fine. Okay, great. So all of you do join the session fastly and do share the session link to all your friends. So children, let's continue our discussion, all of you. Let us start our discussions. As you can see now here, you are seeing the how you are feeling about this thing here, and you can see the Sachin Tendulkar in the your class. You are enjoying the two fellows now here, and myself and Sachin Tendulkar, isn't it? First of all, let us have a brief small announcement from this Unacademy. So Unacademy is conducting the All India mock test for the GATE 2023 aspirants, and the test is from the December 4th to December 18. So this exam is like a real GATE exam. You can experience a real GATE exam with this All India mock test. With this you will get to know where you will stand and what are your weak points, what are your strong points, so that you can able to revise the things according to your weak points. Now you will get the complete video solutions also available, and this is for the both plus students as well as the free students also, YouTube students also. You can use the code BV Reddy to enroll for it. This is completely free All India mock test. This is completely free test series. Right. Chalo, let's continue here. And you can plan this Unacademy subscription with a no cost EMI. Without paying any additional charges, you can able to get the Unacademy subscription with without paying any additional charges. And Unacademy tests, all the complete notes are available, digital notes are available in the website as well as an app. If you want, you can access it. Iconic students will get the hard copies. And these are the new batches we are starting. You can see, have a look at here, and you can find the top educators of India. You can find in the single frame. And so here for the GATE 2024 we are starting with the analog electronics by Aditya sir. And to enroll for this course, you can go for this, use a code BV Reddy to get the maximum discount and personalized guidance from me. And these are the electronics and electrical both, you can see, and you can find the top educators of India here. And these are the new batches we are starting. You can able to access these batches, and Unacademy complete the test series. And so these are the test series, and you can plan the Unacademy test series. You can purchase it now for the 4 month के लिए just $499, and Unacademy light test series. And we have just 3 months away for the GATE exams. So as we know, just 2 months away from the GATE exam, you can plan your preparation properly. Right. So these are the features of Unacademy Plus. The plus students will get the top educators will take the classes, and so digital notes, test series, and iconic students will get additional benefits of customized doubt solving feature is there, and printed notes, one-to-one mentorship, strategy and study programs, and interactive open house sessions. Right. Fine. Now just have a what to discuss in this session. We have discussions. So सबसे पहले, so this all of you do, so everybody might know about myself. I am BV Reddy. So I am going to discuss the electromagnetic field theory for the electrical as well as electronics. As of now, this course what we are discussing, that is purely for the electrical students only. Electrical students. So let's continue our discussion, and this is like the revision course, and I will briefly discuss the concepts, and we'll focus maximum problems, and mostly I will try to finish this course as soon as possible, so that it cannot be burden for you all fellows. And today we are starting at 5:30. Daily we will try to plan 1 hour sessions. Fine, all of you. So let's continue our discussion, everybody, and if you fellows want any other queries and all, and you please discuss with us and do comment in the comment section. I will try to answer. And so here, according to your requirement, I will try to plan the sessions, either YouTube classes and special classes or plus classes. That depends upon your demand. First of all of you please do like and share to the maximum students, all of you. Yeah, this is, and I will briefly cover the theoretical part. Thereafter we'll focus on the problem sessions. This is the crash course. It is not a comprehensive course. So here, and I'm planning to complete this thing as a 15 to 16 hours. I will try to finish it. अगर कोई extra चाहिए तो we can continue. We will take now. As of now, I'm planning to complete this thing within 15 to 16 hours. I will try to finish. For ECE also this topic is required. So as of now, we are covering up to the static electric field, static magnetic fields. Up to the Maxwell's equation I am going to cover in this topic. Right. As you might see, as in the last year you got the nearly 8 marks you got in the GATE 2022 from EMF topic. So that's why all of you need to concentrate on this thing. Okay, fine. So chalo, let's continue our discussions, all of you, everybody. Let's start now. Yes, meanwhile, if you have any other queries in the subject, you can discuss. And I don't want to waste your valuable time and all. I am starting the course. So we'll try to interact with me. अगर कोई doubt हुआ तो directly मेरे से बात करो. You can directly discuss with us. Fine, all of you. And if you want to follow me here, and yes, complete. So here I don't discuss much theory. I will discuss mostly the problem sessions, and it is in the form of concept to the questions. Briefly revise all the concepts, and then I will focus on the problems. And as we are very near to the GATE exam, if I start discussing the theory, so it will takes a lot of time. So I will mostly focus on the revision. So little bit of fast I will discuss. Thereafter we'll discuss the problems. And if you are facing any difficulty in any particular problem, any concept, then I will discuss the corresponding concept. After that I will do the problems. Okay, chalo, let's start now here, all of you here. Electromagnetic fields. What is this electromagnetic fields? Electromagnetic fields is a branch of electrical engineering. Which deals about the interaction or the interplay mechanism between the electric field and the magnetic field. Yeah, you can join these courses. So we'll discuss the concept through questions. You can easily understand all the concepts. Little bit of your 12th class knowledge is required. Other than this, nothing else required here. Electromagnetic fields is a branch of electrical engineering which deals about the interaction or the interplay mechanism between electric field and the magnetic fields. Right. Now, so, and the PDF will be also provided, and so you can, so the complete class notes PDF and DPP will be provided. And if you can follow me in the Telegram channel, you can search in the Telegram channel, you can search. Yeah, I will discuss the vector analysis also. I will discuss that also. I will discuss. Now you can search in the Telegram channel, that is BV Reddy. BV Reddy GATE. You can search there. You do message me here. You can join in this Telegram group. There you can get the complete notes, short notes, PDF, DPPs are available there. You can search in the Telegram channel, that is BV Reddy GATE. Fine. Chalo. The electromagnetic fields, which deals about the electric fields and the magnetic fields. Which will deals about the electric field and the magnetic fields. All of you listen carefully. The introduction of these electromagnetic fields. In these electromagnetic fields, so here first of all, and all of you remember one thing here, this course is for any type of students, whether you did the previously the EMFT or not, so uska bhi chalega. You no need to follow any other things, no, just follow, you can able to understand. अगर कोई डाउट हुआ तो if you are not able to understand any particular concept what I am discussing, and let me know, so I will discuss the in detail topic, I will cover it. Right. So this is what you want, which topic you want, then I will discuss it now here. So Hindi English दोनों में होगा. Hindi English I use both language I use now here. Both Hindi English both I will use it. Okay. So so I hope you are comfortable with the basic language. Basic so I don't use much English also. Basic, very basic English I use, and basic Hindi I use. Okay. चलिए. All of you ध्यान से सुनो इधर. Look at now here. Electric fields, and there you can see हमेशा आपको ये दिखेगा. So this is E. Where electric field E. What is this E is called as a? Where this electric field E here, which we used to call this as a electric field intensity. E is called as what, you tell me? That is a electric field intensity. E is called as what? Electric field intensity. And the units of electric field intensity is what? Volts per meters. The units of electric field intensity, which is volts per meter. In magnetic field, corresponding to the electric field, in magnetic field we use one term that is called as a H. Where what is this H you see? Where H is called as a magnetic field intensity. Where H is called as a magnetic field intensity. H is called as what? Magnetic field intensity. The units of the magnetic field intensity, which is given as, that is amperes per meter. Where H is called as a magnetic field intensity, the units of this magnetic field intensity is what here? Amperes per meters. Right. Next, in the corresponding to electric, in the electric field we have one more term that is called as a D. Where D is called as a electric flux density. What is D is called as a electric flux density. D is called as a electric flux density. The units of the electric flux density is coulombs per meter square. The units of the electric flux density is, and सभी ने मेरे साथ repeat करो, everybody. All of you do repeat with me. Repeat करो मेरे साथ. So ताकि ये सारा word, सारा terminologies भी आपको घुसेगा directly. So here repeat करो मेरे साथ. Repeat करो मेरे साथ. Okay, all of you repeat with me, along with me. Next, corresponding to D in the magnetic field, we have a term that is called as a B. Where what is this B is called as? Tell me. What is the B is called as a magnetic flux density. B is called as a magnetic flux density. Magnetic flux density, and the units of this magnetic flux density, which is equal to what? The units of the magnetic flux density is a Weber per meter square. Units of the magnetic flux density is Weber per meter square. Weber per meter square. In addition to this, we have one more unit we have. What is that? Tesla. Weber per meter square. The other unit is a Tesla. Weber per meter square equal to Tesla. Right. And all of you ध्यान से देखो इधर. In electric fields, we have a E electric field intensity and electric flux density. Magnetic field, we have a magnetic field intensity and magnetic flux density. Magnetic field, we have magnetic field intensity, magnetic flux density. And so, and there is a relation between these two. We have a relation between the E and D. The relation between E and D, which is given as what? D equal to what? Epsilon E. The relation between D and E. D is given as what? Epsilon E. And the relation between H and B, that is what? B equal to what? Mu H. B equal to mu H. So this is the relationship between D and E, and this is a B and H, right? Where epsilon, where this epsilon is called as a electrical permittivity. Epsilon is called as a electrical permittivity, and the units of this electrical permittivity is a farads per meter. Farads per meter. And mu is called as a magnetic permeability. Mu is called as what? Magnetic permeability. Where epsilon you can find in electric field, हमेशा आपको epsilon दिखेगा. In electric fields you can see only epsilon. You can see electric fields are affected by epsilon only. Magnetic fields are affected by the mu. Magnetic fields are affected by the permeability. So this, in the while you are discussing the electric fields, there you can see the term hamesha epsilon only you can see. And when you're talking about the magnetic field, so you can see only the mu term only. Don't get confused here. Always hamesha electric field के लिए electric permittivity, magnetic field के लिए magnetic permeability. Right. Next, where epsilon in general, which is given as what? That is epsilon r into epsilon naught. Epsilon r into that is Henry per meter. The units of this permeability is Henry per meter. Epsilon is given as epsilon r into epsilon naught. Similarly, mu is given as, that is mu r into mu naught. Mu is given as mu r into mu naught. ठीक. So hope all of you सभी ने कॉपी किया. Done. Right. Now let us talk about what is epsilon r and epsilon naught. Where epsilon r, which is called as a relative permittivity. Epsilon r is called as a relative permittivity. Epsilon r हमेशा greater than or equal to 1. And mu r is called as a relative permeability. And mu r, which is also greater than or equal to 1. Right. And this epsilon r, which is equal to 1 in case of a air or free space. Air or free space, epsilon r is 1. And this mu r, which will be 1 in case of a air, free space are non-magnetic mediums. Non-magnetic mediums. Non-magnetic medium means what? The medium which does not have any magnetic nature. That type of mediums are called as a non-magnetic mediums. Daily 1 hour class, right? And epsilon r we have seen epsilon naught, which is given as 1 by 36 pi into 10 power minus 9 farads per meter, and which is given as 8.854 into 10 power minus 12 farads per meter. Fine. And similarly mu naught, which is given as 4 pi into 10 power minus 7 Henry per meter. Right. These are the relations we have. The total number of hours to complete up to the electrical part, it will be around, in this revision session we are planning the around 16 hours I have planned. 16 hours I will try to finish. If it is required, we can add additional hours. Right. So these are the terms we can see now frequently in the electric fields and the magnetic fields. These are the frequent terms we can use in the electric field and the magnetic fields. Right. And in addition to this, you can find this some other terms, as you can see here. That is, in general, this epsilon r, which is given as 1 plus chi. Epsilon r, which is given as 1 plus chi. Where this, what is chi is called as a, which is called as a electric susceptibility. What this is called as a chi, this is called as a electric susceptibility. This is called as a electric susceptibility. Similar to that, mu r, which is given as 1 plus chi m, where this chi m, which is called as a magnetic susceptibility, which is called as a magnetic susceptibility. Right. So these are the terms we can find frequently in the electric fields and the magnetic fields. Done all of you? So till now जो whatever we have discussed, इसमें कोई doubt हुआ तो पूछो जल्दी फटाफट. Any queries you have on this related this topic till now what we have discussed? So in electric fields you can see frequently electric field E and D terms. Magnetic field and H and B terms. The relation between B and H is given as D is equal to epsilon E and B is equal to mu H. Fine. Right. चलो हम आगे बढ़ेगा, बोलिए. Let's move on here. Tell me all of you. चलो. Next, and let us briefly discuss about the coordinate systems. Coordinate systems. So let us talk about the Cartesian coordinate system. In Cartesian, susceptibility means it will indicate the how sensitive the given material to the applied field. Let us consider I have taken some object we have taken. Let us consider we have taken some object we have taken. This object, so here on this particular object, if I apply certain amount of force, then that can be withstand. If I apply the more than that, then it will break into two pieces, isn't it? Exactly similar to that, any medium can capable of capable of, so it can capable up to certain amount of electric field only. If we apply the more than that, what happens now here? So the breakdown will takes place, and it does no more it is a material, it will be act like a what now here, the medium properties completely changes. Okay, so the susceptibility will indicate that how much the maximum electric field I can apply so that the medium can be in a proper working state. That maximum value is called as electric susceptibility. Exactly similar to that magnetic susceptibility. And so some mediums can capable of storing a certain amount of magnetic energy only. Beyond that, it cannot store the energy. So those will be measured by the how much it can able to store will depends upon the electric susceptibility and the magnetic susceptibilities. Fine. The susceptibility, it is nothing but what we can, in short form, what we can say here, how much electric field or magnetic field the medium can withstand. Based upon that only, so here हम आगे भी discuss करने वाला, the concept call it as a breakdown. In the capacitor, you might heard about the breakdown. What is the breakdown voltage? Have you heard this thing? Breakdown voltage and all. So those are related to this concept only. And the medium between the two plates of a capacitor, we have a dielectric. And if we apply certain amount of electric field, then only the medium can work. Otherwise, it will behave like a short circuit now. That's what we are discussing. Right. And why electric field does not exist inside a conductor? Himanshu, you will get to know this thing when you discuss the Gauss law. I'll prove the things now here properly. So here I'll prove this thing here. Why there should not be any electric field? Not only electric field, magnetic field also cannot be exist. And electric field cannot exist. Why it is there? I can prove this thing when you are discussing the Gauss law. At the Gauss law case, I will discuss it. And if I miss that one, so do remind me. I will discuss this topic clearly with the examples and yes, exactly. So here that what you might heard about this as a this thing what we can say corona discharge. You might heard about the corona discharge. Yes. Now so here 3 into 10 power 6 is the breakdown voltage for in case of a air. If it is more than that, then what happens now? There is a short circuit can happens. Have you might heard about this thing has a this thing what we can say lightning. How the lightning will come? You see this thing here. What is the reason for the lightning? So here during the lightning, what happens now here? Whenever the sky potential, so sky potential and earth potential. So there is a huge difference between the sky potential and earth potential. Then what happens now here? The medium between these two, it will be work like what you tell me now here. It is work like a dielectric. So then the medium will get ionized. Then huge amount of energy will be pushed from the clouds to the earth. Isn't it? If there is a huge the exactly working of a capacitor, in that case what happens now here? The sky will behave like a positive potential, positive conductor, and the earth will behave like a negative conductor. Whenever there is a huge potential difference between these two conductors, then a maximum huge amount of energy will be discharged from the positive conducting plate to negative conducting plate. That we used to call it as a lightning. So here basically here there are so many interesting things you have to learn in the electromagnetic fields. So many practical. So as you know, this basically electromagnetic field, the basic fundamentals of physics. So that's why it has so much all the practical application you can find here. And so I will try to make this subject is more interesting with a real-time examples. And this subject will be very much helpful in your other subjects also. Networks, especially for the networks, your machines and power systems also you can able to see. And the networks used to talk about the concept, call it as a breakdown, isn't it? And there you might heard about the capacitor allows only the AC, capacitor does not allow the DC. Capacitor allows only the AC, it does not allow the DC, isn't it? So why it is? And in case of capacitor, when you're talking, we used to talk about the transient state and steady states. In transient state, how the capacitor will behave, short circuit, and in steady state how the capacitor will behave, open circuit. Why they are behaving like a short circuit and open circuit? In the networks, the learning, it is a very limited. You might learn those things in the in the mathematical equations, and in the electromagnetic fields you will get to know what are the physical meaning of the transient state, what is the physical meaning of steady state. आपको पता चलेगा, real feeling इधर आएगा आपको. And even we have, and the best example you can see now here, this is like your machines you have studied, and we have different type of electromagnetic fields. EMF we used to talk about what now here, statically induced EMF, dynamically induced EMF, isn't it? So why we have statically induced EMF, dynamically induced EMF in the, so there what we have studied the mathematically you can understand, but the actual ये concept कहाँ से आएगा? Why we have when the rod cutting the flux lines we have EMF. ये EMF कहाँ से produce होने वाला? What is the reason to produce? ये सब कुछ आपको electromagnetics में पता चलेगा. Right. चलिए let's continue here. Don't worry. So here all these things real time examples के साथ हम करने वाला ये topic. अगर so here कोई doubt हुआ तो मुझसे बात करो. We'll discuss the things. चलो let's continue our discussion now here. Yes, now here fine. Let's talk about the coordinate systems. The first one, सबसे पहले Cartesian coordinate systems. And to understand this thing, you need to have a little bit of mathematically strong also will be required. The coordinate system and vector calculus is also required. So you will get to know. Yes, exactly. Electromagnetics is the very father of all electrical engineers. So without knowing the electromagnetic fields, learning the other subject means, I will simply say it is not at all a good thing, isn't it? As it was given by the great scientist, you might heard about the fellow, that is, he is a fellow. You might I think all of you might know about this fellow. Have you seen this fellow here? The great fellow, so here the great scientist, that is Nikola Tesla, isn't it? Exactly. So here everybody has to know about the great scientist Nikola Tesla. So this is the book, and this is the autobiography of the Nikola Tesla. It is one of the great book. If possible, and all of you do read this book at least once. My Inventions. The title of this book is My Inventions. If possible, you can. This book is freely downloadable also. You can able to download. You can able to read this book. It's one of the great books. This book is always हमारे साथ होगा. I'll keep so this thing with me only always. Chalo. Let's continue our discussions. Coordinate systems. Now, here this coordinate axis which we have, this is x comma y comma z. Coordinate axis what we have, x comma y comma z, right? Now in this, so here the coordinate axis we have x comma y comma z. There I am going to discuss here, if I have any vector, how we can express the vector in a Cartesian coordinate system, you tell me. I will call this as x-axis, and this is my y-axis, and this is my z-axis. And this coordinate axis, and we are taking the unit vectors along x direction, which we have taken it as a ax cap. And along y direction, we have taken it as ay cap. Along z direction, we have taken it as az cap. So if you have any doubt in any topic, you can directly ask. I will try to rectify the doubts the best manner. I will try my best. Right. Now, so as you know here, you might know if we have any vector A, the vector A in a Cartesian system we can express as what you tell me? Ax into Ax cap and Ay into Ay cap plus Az into Az cap. And you can see now with capital Ax, capital Ay, capital Az are called as a components of X, Y, Z. Yes, Rahul, you can do follow this thing here. You are the first year now here. So here and your seniors are very near to the exam and also if I can able to discuss about you, so your seniors time will get wasted. They has only 2 months only to for this GATE exams. I need to concentrate on the your seniors. Okay, so you can join the session daily regularly. You can join. You can complete the syllabus. Okay. And where Ax cap, Ay cap, Az cap are the unit vectors. Unit vectors along X, Y and Z directions. Now you have to remember this thing here as we know. What is the Ax dot Ay? Ax dot Ay, which is equal to what now here? I dot J. What will get you tell me? Ax dot, what is the angle between Ax, Ay, Az? Tell me first of all. The angle between the AX, AY, AZ is what you tell me now, tell me. So which is 90 means are the equal to each other. What is the AX dot AY? AX dot AY which will becomes what you tell me now here 0. Dot product will become 0. Right. These are perpendicular to each other. Next AY dot AZ and which is 0. Az dot Ax which is equal to 0. Right. Tell me now here Ax dot Ax. Ax dot Ax is 1. Ay dot Ay which is equal to 1. Az dot Az which is equal to 1. Right. Next Ax cross Ay. What is this Ax cross Ay? Ax cross Ay which is equal to what you tell me now here Az. Ax cross Ay which is equal to Az. Now this Ay cross Ax. Ay cross Ax which is equal to what you tell me minus Az. So ये सभी को क्या था ना बोलिए, यहाँ तक ये सभी को क्या था ना, इसमें कोई डाउट हुआ तो पूछो जल्दी. राइट. Right. Now so here you do remember this thing as like this. We have Ax, Ay and Az cap. The cross product, whenever you do the cross product now, Ax cross Ay will give Az. Ay cross Az is a Ax and Az cross Ax which is a Ay. If I move like this then it is a positive. Fine all of you? Right. Yes, time varying fields Maxwell's equation required. Up to Maxwell's equations are required. Up to Maxwell's equations we have to learn. And up to the electromagnetic fields. Basically the main purpose of the introducing the electromagnetic fields in the electrical syllabus is you need to understand the concept of EMF concept. We have two types of EMF we have now. Statical induced EMF, dynamical induced EMF. To understand the actual feeling of the statically induced EMF, dynamical induced EMF, this electromagnetic field has been introduced for the electrical syllabus. And before that, before the GATE 2014, So this EMF is not in your electrical syllabus. Now they, from the 14 onwards only, they introduce these topics. Earlier, so electrical fellows doesn't have a very importance for the EMF. 14 onward they change the syllabus. Right. Fine, all of you. Next. Now, so we should call now here, let us call the differential length. Differential length. This word you can see very frequently. Try to understand. What is meant by differential length? Differential length, which is a change in length. Differential length means what we can say, change in length. Consider we have taken the 2 points we have taken somewhere. I have taken the 2 points I have taken. Let us consider this point which is equal to A, and this point I am calling this as a B, and there is a distance from these 2 points, small distance we have considered. Let us say coordinates of these points are something x comma y comma z, and the coordinates of this B is something x plus dx and y plus dy comma z plus dz. A small change, where what the dx is a dx the change in length along the x direction, dy the change in length along y direction, dz is the change in length along the z direction. So the change in length when I move from point A to point B, that is called as a differential length, and which is given as what I can say here, dx. Where what the dx you tell me? Dx is the magnitude of change in length along the x directions. Since this is the magnitude and this is the vector and the direction is along what direction? X direction. So I can use corresponding unit vector, I can use it. Right. And dy along what direction now here? Ay. Next, dz into az. These are the change in length along x, y, z directions. Is it fine, all of you? Differential length which is given as dx into ax, dy into ay, and dz into az. Right. Next. Now I will call the term that is called as a differential surface area. Differential surface area. This is also another most important parameters. All of you listen carefully. So let us consider we have some plane here. We have consider this plane which we have taken as easy purpose xy plane we have considering. This is my xy plane. Now in this plane we have some object is there. Consider here is some object we have. This will have area, isn't it? Now I can small part we have considered the small length along this x direction, which we will call this as a dx. This is along x direction now, and this is along what direction? We can say small part, this is the dy. Now if I ask the what is the area of this part, small part of area, which we used to discuss, which we used to denote this thing as a ds, area, and the area means what now? L into b. So this is dx into dy, so it will give us a magnitude of area. But the surface area is a vector quantity. We need to give the direction also, we have to mention. We need to give the direction of the surface area also. What could the direction of surface area, that we need to identify. What the direction of surface area, you tell me now here. So the direction of surface area which will be always the perpendicular to the plane. So agar, let us consider small example now here. All of you ध्यान से देखो इधर. Look at now here, all of you. Consider this is my paper we have taken here. All of you listen carefully. Now this will have area. Everybody tell me first of all, it will have area or not? Now just imagine now here. Just imagine now here. This is my x-axis and one is y-axis. This is x-axis. This is my y-axis. Now all of you ध्यान से सुनो here. If I am seeing from this paper from the top view we are seeing now here. If we see from the top view, then only I can able to see the length as well as width. अगर आपने ये पेपर को आपका साइड से ऐसा देखा, इससे देखा, you are looking from this side, then how it will appears to you? Tell me everybody. how ये आपको कैसा दिखेगा बोलिए? You are seeing from this side, it will be just appear like a line. Yes or no? So it's just appear like a line. But if you see the from the top side, then I can say that this is a having area. That means to say this will have area, I need to see this thing from the what direction? You tell me now here. I need to see this thing from the top view. Then only I can say this will have some area. Right. So from this what I can able to conclude? You tell me now here. The direction of surface area, which is what direction now here? Perpendicular to both x and y. Which is perpendicular to x and y? Tell me. That is AZ. Everybody. So this will call this as a differential surface area. Which plane is this? You tell me. This is called as a xy plane. This xy plane, which we can also call this as a constant z plane. Xy plane, which we can also call this as what? You tell me. Constant z plane. Now from this understanding, can you tell me now the direction of surface area and the magnitude if my plane is lies in yz plane? If it lies in yz plane, can you tell me the direction of surface area and magnitude? Tell me all of you. Which is given as what we can say here, dy, dz, and what direction I can say, ax cap. Of course positive or negative ये बाद में पता चलेगा. You will get to know later positive negative we can decide. Just I am taking the positive I am considering here. So this is called as a constant what plane? X plane. Everybody. Next ds, and which is given as what we can say here, ds, and which is given as in case of a zx plane. Tell me now here zx plane what we have, area which is given as that is dz and dx, and which is along what direction I can say, ay cap. So this is also called as a constant what I can say, y plane. Everybody tell me. Right. The next one. Differential volume. Differential volume. So which is given as dV. Basically the first observation is volume is a scalar quantity, and volume के लिए we required three variables are required. So we require the x required, y required, z also required now here. So we can say dx, dy, dz. Dx, dy, dz. X, y, z direction change in lengths are required. Fine. So this is about the coordinate systems we have seen. And there we need to talk about another most important thing here. Here is so we'll discuss about the vector calculus topics also. This is vector calculus. The vector calculus, all of you listen here. There one of the most important thing we need to learn here, it is that is a divergence. Divergence of a vector. Once you understand what is the physical meaning of a divergence of vector, you fellows will enjoy the electromagnetic fields very much. So here let us talk about what is meant by actual physical meaning of a divergence. So the physically the divergence physical meaning which is given as a, so that is a dot product and all, that is a only mathematically try to understand the physical meaning which is given as, that is a net rate of flow. What is the meaning of divergence is a net rate of flow is called as a divergence. The word try to understand the meaning of a divergence. Divergence basic meaning means simple word we can say, that is a simple word we can say leaving nature. Simple word we can say here our normal language we can say leaving. And the technically which we used to call this as a net rate of flow. Technically which we used to call this as a net rate of flow. If anything is leaving, we can call that is called as a diverging, moving away, expanding nature, spreading nature, moving away nature, that is called as what? Diverging nature. Away, spreading this entire region, that is called as a diverging. Leaving nature is called as a diverging, simple word, right? Now for example, if you have considered the things now here, let us say I have taken some point. At this point, let us say here we have something is leaving from this point, like this. If we have the nature like this, yes, from this point which is leaving, then what I can say now here, this point is the source for all these things now here. So what I can say now here, so at this location we have a diverging. Now if I simply put a hole to some balloon, if I put a hole, that means what I can say, so the air will be complete diverging. That leaving nature, expanding nature is called as a diverging nature, isn't it? Now so here at this location, this field, now this point is giving all these things. So at this point what I can say, it has a positive divergence. We'll call this as this point is having a positive divergence, right? If I taken some other location, let us consider we have the field is like this. Now I can call this as a negative divergence. At this location we have a negative divergence. The best example what we can say now here, and the positive divergence is at the location of a sources. At the sources we have positive divergence. At the sink we have a negative divergence. At the sources we have a positive divergence, and sink we have a negative divergence, right? Now so here let us try to understand the meaning of the divergence in our subject, right? The thing is, in entire our electromagnetic fields we need to do the research on the four important equations. Those are called as a Maxwell's equations. Those are called as, what you tell me now here, Maxwell's equations. You try to understand the meaning of these Maxwell's equations. Our entire analysis is to understand the Maxwell's equations. If you see carefully, the one of the Maxwell's equations which is given as, that is del dot D is equal to rho v. You will get to know what is this rho v and all, बाद में आपको पता चलेगा. Just understand the physical meaning. And the second another equation for the magnetic fields which is given as a del dot B equal to 0. all of you ध्यान से देखो, इधर ध्यान से देखो. Now as we know that D is equal to epsilon E, right? D equal to epsilon E, and the B is equal to what you tell me, mu H. B equal to what you tell me, mu H. Let us understand the meaning of these equations here. Now I can place a D here. Then by simplifying this equation हमको क्या मिलेगा, देखो इधर all of you, del dot E which is equal to what I can say here, rho v by epsilon, and here I can call this as a del dot H which is equal to 0. ध्यान से देखो इधर, Yes, look at the two equations now here. Del dot E is equal to rho V by epsilon and del dot H is equal to 0. You need to understand the meaning of these equations. And first of all, what is the E here? Tell me everybody. Where what is the E is a electric field. Here how to read the equation, you see here all of you. How you will read this equation? Divergence of electric field equal to something non-zero. Divergence of electric field which is non-zero. Whereas divergence of magnetic field is what? Zero. सुनिए divergence of electric field is a non-zero quantity whereas divergence of magnetic field is a zero quantity. अभी आपने क्या ध्यान देना पड़ेगा इधर, why the divergence of electric field is a non-zero, why it is zero in case of a magnetic field, इस पर आप concentrate करना पड़ेगा. Understood what I am saying here? Everybody, देखो इधर, इस पर हम रिसर्च करेगा इधर. देखो इधर. Now, as you might know about the things now here, if we have some positive charge is there Q. If we have some positive charge is there Q. So tell me how we have electric lines, you tell me. How we have electric field lines are like this. Hana बोलिए. How we have the electric field lines? Electric field lines which are radially outward, which are like this now here for positive charges like this radially outward directions. Now can you tell me now this nature, the electric lines are diverging nature or not? Tell me here. These are what I can say now here. These are the electric field lines or flux lines which we used to call. How this nature, अगर आपको ध्यान से देखा तो how these lines you see this thing here, these nature or not, आपको कैसा दिख रहा है ये वाला? How these are leaving nature, isn't it? Since the electric field lines are diverging nature, because of that, so that's a reason the divergence of electric field which is a non-zero quantity. Since the nature of the electric field is a diverging nature, that's the reason the divergence of electric field is a non-zero quantity. अगर आपने देखा तो here let us talk about this magnetic lines. If there is any flow of, yes, if there is any flow of current through the conductor, then we have a magnetic field lines around the conductor, you tell me. We have the magnetic field lines like this now. So many magnetic field lines we have. All of you boliye. These are the magnetic flux lines which we used to call. Tell me now how the nature of this magnetic field lines, you tell me. How the nature of this magnetic field lines, you tell me what nature. These are always around the conductor. Is the lines are leaving away from the conductor. The magnetic lines are always like this only. And these lines are not leaving from this conductor. So from this, can you tell me now here, is the magnetic field is leaving nature? Is the magnetic field lines are leaving nature or not? These are not a leaving nature. Not leaving means not a diverging nature. Since magnetic field is not a diverging nature, since magnetic field is not a diverging nature, that's why the divergence of magnetic field is what? That's why the divergence of magnetic field is what? Zero. That's why the divergence of magnetic field is zero. Since magnetic field lines are not a leaving nature, not a leaving field, that's why the magnetic lines divergence is a zero. But whereas electric lines are kaun sa nature, kya nature? Electric lines are diverging nature. Electric lines are diverging, इसीलिए divergence of electric field zero नहीं है. बोलिए. Right. That what? This is the most important thing here. So there are two Maxwell's equations. The another most important thing what you are going to learn here, it is in the here, that is a curl of a vector. Curl of a vector. Here the curl means will use the, so here, so how much field is rotating. Why? So here these are electric lines are outward and magnetic field lines are circulation. So this thing here, we can't say why it is like this. The things are the nature of the electric field is diverging. So we are studying about those things. Those are the internal property. Inherent property of electric lines is diverging. Magnetic field is rotational. Why it is like this and we can't say, but thing is we are studying about those things and we are taking the help of those things, and once you understand those things, we can able to utilize those things our practical applications. Okay, so those are the internal properties. So those properties we don't know. So you can say how the earth is rotating, how the earth is round. So these words we have not, these things we don't know. These things. So the thing is, but why? So here the application is the nature we are studying, and by doing this thing here, we can utilize in our practical scenarios. Fine. The curl means it will give a rotation. It is a rotation. Now, as we have discussed the two Maxwell's equations which are related to the electric field, and magnetic field. The another two Maxwell's equations we have which are based upon the curl concept. One of the Maxwell's equation which is equal to, and of course, and all of you dhyan do, here we are talking about the static electric field. And I am talking about what you tell me now, static fields I am talking. For static fields, what are the Maxwell's equation for static fields are one of the equation which is given as, that is del cross E which is equal to 0. The other equation for magnetic fields what we have, del cross H. Can you guess क्या होगा? Del cross H which is non-zero. अभी बोलो इसका मीनिंग आपको बोलो ध्यान से. Del cross H is non-zero. That means what we can say, the curl of the static electric field is a 0. So here the curl of a static electric field is 0. Why 0? अभी बोलो why 0? बोलो मेरे साथ, सभी ने बोला पड़ेगा. So here why the curl of electric field is 0? What is the meaning of curl? Means what? Rotational nature. Curl means what now here? Rotational nature. I am talking about what you tell me. Yes, what now here? What is the nature of this electric field? You see this thing carefully. It is what nature? It is not a rotational. It is what nature? It is a diverging nature. Yes, Hana boliye. Since the electric field is not a rotational field, इसीलिए what I can say, electric field, the curl is 0. And whatever the magnetic field nature is, what? Magnetic field nature, it is a rotational nature, isn't it? So that's the reason magnetic field is a rotational field. That's why its curl is non-zero. Is it clear now? Abhi boliye. So here that is the physical meaning of the Maxwell's equations. Now अगर आपने so here let us consider the previous equation भी आई ना, previous equation क्या आया इधर, you can see now here, that is previous equation we have, let us combine those things. That is what we have the equation now here, that is del dot E which is non-zero. Now you tell me the previous equation, that is del dot H and which is equal to 0. Right. Now you tell me now here, from this combining these equations, can I conclude something? By doing this thing, combining this thing, can I conclude something here? So what I can say, the nature of a static electric field, I want the nature. Can you comment about this nature of electric field? The nature of a static electric field is what nature? What nature? It is a diverging nature. Diverging but not rotational. बोलिए. Diverging but not rotational field. Hana बोलिए. And what about the magnetic field nature? Tell me. What about the magnetic field का nature बोलिए. Magnetic field is what nature? Which is a rotational but not diverging. Rotational but not diverging. बोलिए. This thing, so here if we can, so the main thing of this complete electromagnetic field is what? To understand the Maxwell's equations. We are studying this completely, this electromagnetic field. Main purpose is to understand the physical meaning of the Maxwell's equations. Once you understand the physical meaning, so then you can enjoy this topic like anything. Right. So this is simple word what we can say here in electromagnetic. In the interview questions, if somebody asks what you learn in electromagnetic fields, nothing. So we just study about the nature of electric field and magnetic field. The nature of electric field and magnetic field. What is the nature of electric field? Diverging but not rotational. And nature of magnetic field is a rotational but not diverging. That's all. Then if we can able to answer this thing here, then the interview panel member will get to know you are very good in this electromagnetic field. Then immediately, so then the interview panel member never ask any question on electromagnetic fields. Since you are very good, he will get to know you are master in the electromagnetic field. He will skip to some other subject. Right. Understood what I am saying here, all of you? Everybody? Right. Right. That's all. Exactly. So those equations we are going to derive in this thing. So whatever the four equation we have studied this thing, right? So this four equation we are going to study here. We are going to study. We are going to derive this all the four equation we are going to study in our subject. Nothing else. Nothing else. So here, like this. That what we are going to study. Nothing else we will do here. So I think सभी को आज का क्लास में बहुत मजा आया होगा. I think so. I think आप सभी को, so you fellows might be enjoy the session, isn't it? Right. The Maxwell's equation आपको, so here we used to have a इतना डर होगा ना, nothing. Maxwell's equation, nothing. So Maxwell's equation, what will give Maxwell's equation? Maxwell's equation will give the simple word we can say what you know about Maxwell's equation. Maxwell's equation will give the nature of electric field and magnetic field. Maxwell's equation will give the what is the nature of electric field, what is the nature of magnetic field. That's all. Right. Yeah. Is it fine? So अगर कोई डाउट हुआ तो पूछो इधर. Yes. If you have any queries and all, let's discuss. Right. XY plane. देखो इधर XY plane. So you see this thing here. Can you tell me the plane here? We have taken, this is my x-axis and this is my y-axis. I have taken this thing. Can you tell me now here? इसमें now अगर आपने ध्यान से देखा तो if I have taken this point, if I move from here to here, can you tell me now what are the variables from here to here? Can you tell me what are the variables from here to here? बोलिए क्या वेरिएबल होगा इसमें? Have taken this point, we have taken, right? So this point to this point here, exactly. So we are, so here, okay, next class we have so here, not tomorrow, day after tomorrow we have at 9 p.m. Day after tomorrow we have 9 p.m. we have a class. December 1st onwards will continue daily, will continue the class at 9 p.m. will continue. Okay, if I move like this, x value changes, isn't it? Only x value, I am moving parallel to x axis here. What is the variable? X value changes. If I move parallel to y axis, y value changes. Next x value changes. Next y value changes. Now in this entire my path, you tell me now what are the variables here, tell me. इसमें entire path में what are the variables, you tell me now. केवल x and y value changes. So z value हमेशा constant है ना? हाँ ना, बोलिए. If I move from here to here, so x value changes from here to here, y value changes from here to here, x value, yes, y value. Right. So that's why in entire this thing here, what are the variables, you tell me. X value changes, y value changes, but लेकिन z value constant आई. इसीलिए which we used to call this a constant z plane. Right, xy plane, that is also called as a constant jet plane. So tomorrow no class, we have a, on December 1st onwards will continue the regularly, will continue the class at 9 p.m. At 9 p.m. we have a class regularly in the same YouTube channels, and regarding this material and this notes and all, you can do follow me in the Telegram channel. You can message me there. You can, that is a BV Reddy GATE. You can message me in the Telegram channel, that is BV Reddy GATE. And in the Unacademy also you can follow me, my free classes and special classes you can able to follow. BV Reddy GATE. You can search this, there you can find. There you can find my channel, you can find Telegram group. Telegram. Fine, all of you? Yeah, that's for the today's session, and we'll meet tomorrow. All of you bring whatever the doubts you have, you bring your doubts. Yeah, in this session we'll try to cover the all the electrical PYQs and most expected questions we'll try to cover here. And we have nearly 400 problems I have collected for this electromagnetic fields. All these problems we'll try to cover it. We'll try to cover the maximum problems, we'll try to cover it. It includes all the PYQs and DPP etc. will contains. Okay, all of you do regularly follow the classes, and the Telegram channel you can join in this group, and you will get the regular updates you will get. Now I will provide the complete short notes, I will be provide, and I will short notes, and these short notes I am prepared. You can have a look at now here. This is the brief short notes I have prepared like this. This is one page of short note. The complete short notes I will provide you for the electromagnetic fields. Right. So have a look at the short notes here. How I have taken a lot of care to prepare these short notes. Fine. Yeah. So that's for the today's session, and we'll meet in the next session. Okay then. See you. Bye bye.